You're listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology.
Hey everyone, good afternoon and good evening. My name is Bob Keane. I'm the editor-in-chief of the internationally renowned journal Fire Ecology. Fire Ecology is a journal that is published by Springer Nature and managed by the Association for Fire Ecology. Today, we have three people talking about a very, very exciting paper. I couldn't put it down when I started reading it. The name of the paper is Assessing Fuel Treatments and Burn Severity Using Global and Local Analyses. And we have three people to talk about that, three co-authors, Astrid Sanna, Alina Cansler, and Craig Bienz. Astrid, would you like to introduce yourself?
Yeah, sure. Hello, Bob. My name is Astrid Sanna, and I am a research scientist affiliated with the Forest Resilience Lab at the University of Washington in Seattle. Thank you for having me.
Thank you for coming. And Alina, do you want to go ahead and introduce yourself?
My name's Alina Cansler. I'm an assistant professor in forest management at the University of Montana.
And Craig, you're up last. Could you talk about yourself?
Yes, good morning. I'm Craig Bienz. I work as a landscape ecologist for the Klamath tribes, but when this paper was written, I actually worked for the Nature Conservancy as a forest ecologist.
Well, welcome all of you, and it's a very exciting paper. Astrid, tell us about it.
So in this study, we zoomed in on an 1,800-hectare section of the Bootleg fire near the Second Marsh in South Central Oregon to evaluate how fuel treatments, fire suppression operations, and other burn severity drivers affected burn severity, all under constant fire weather conditions, which remove the confounding effect of the weather. Additionally, we worked closely with the land and fire managers who implemented the fuel treatments and led the fire suppression operations during the Bootleg fire, and this really allowed us to access highly accurate treatment histories and on-the-ground knowledge. But I believe that what sets this study apart the most is the application of Shapley additive explanation analysis, which allowed us to quantify the influence and interaction of every burn severity driver and explain their effects at the scale of individual observations while still capturing the broader patterns across the study area. So if you're interested in applying a reproducible framework to explain how fuel treatments and other burn severity drivers affect burn severity, and in learning more about how successfully broadcast burning mitigated burn severity during the Bootleg fire, I think that this study is really worth a look.
Yeah, I agree. It was very interesting. And I really enjoyed reading, and I thought your methods were incredibly cool. Can you tell us a little more about them?
Yeah, sure. So as I mentioned earlier, we use SHAP analysis to explain the results from our random forest model. And this approach is broadly applicable to most machine learning black box models. And what makes SHAP special is that it captures interactions among variables and tells you for every single sample point whether a particular variable value increase or decrease the predicted burn severity, and also by how much. And so by using the spatial coordinates of each sample point, we were also able to map those effects across the study area. And that really gave us spatially explicit visual insights into burn severity drivers, revealing patterns that would be hard to see in a scatter plot.
Yeah, I thought that was really cool the way you did that. So let's get to the meat of the paper and let's take a peek under the covers. Can you tell us a little about what you found? What are the results?
Yeah, so in a nutshell, units treated with broadcast burning had the highest percentages of area burned at low severity. And in our analysis, broadcast burning really acted as a proxy for surface fuel loads, weakening the influence of canopy cover on burn severity. And the other top drivers were also related to fuel characteristics by indirectly capturing fuel accumulation, structure, and continuity, and really highlighted how fuel plays a key role, even though, as we know, it's often confounded by fire weather and other bioclimatic and topographic factors. And finally, while we didn't quantify this directly, I believe it's worth mentioning that we learned from the fire manager that all treatment types facilitated firefighters' work during the suppression of the Bootleg fire. So that's an anecdotal but valuable piece of the story, I think.
And that's really interesting. And not only that, I think these results are going to be really interesting for managers. Craig, can you tell us a little about that? What do you think the management implications are of this study?
Well, what I've been learning since the paper's been published, I've had a few years to deal with forest managers and forest ecologists since this fire, but understanding that the footprint of the Bootleg fire, the third largest fire in Oregon's history, Ponderosa pine ecosystems with trees over 300 years old persist, where ecological processes of fire restored resistance to drought and extreme heat and resilience to high severity fire. To perpetuate ponderosa pine forests, therefore, managers must incorporate fire with cultural and broadcast burning. This is a new twist, I think, especially for industrial forest managers. The results actually provide an economic and cultural benefits of fire, which have been now quantified through this analysis. And I think the other part that's really amazing for some folks is broadcast burning alone can be as effective as combined thinning and burning treatments to mitigate burn severity.
Wow, that's cool. Yeah, I'm sure a lot of managers will be interested in that.
I think we've gotten kind of a good overview of the unique methods that Astrid's really dove into, but bringing it back to some of the challenges we faced in understanding fire regimes and fire impacts across landscapes, we've done a really good job understanding large-scale eco-regional level processes in terms of fire severity and burn severity. And we've always had a challenge understanding what's driving things kind of in this middle domain. It's really hard to predict things without enough replication, given all the contingent relationships between varying fire weather, varying field conditions, varying topography. And what we've really gotten out of this is a method for looking at the effects when the relationships between drivers are contingent or interactive. There's a lot of ongoing work looking at field treatment effectiveness right now. And some of that work has used machine learning models and random assignment of controls, but being able to also pull apart these analyses using the SHAP analysis method to look at local scale drivers and contingent relationships is just really opens up a lot of room for increased interpretation. I think I want to highlight one thing that I thought was really interesting, and I was really excited when we first saw these results, was we wanted to know about the effects of firefighting during the fire. But it's really not that important in terms of the local scale model. It's like number 15 on the predictor ranking. But with this analysis, we were able to see an interaction between firefighting and previous broadcast burning that showed that when those two things happened in combination, there was more of a decrease in burn severity. That might really let us get at some of the human factors during the fire, along with these landscape fuel and treatment factors.
Wish we could talk about these results forever, but we only have a few minutes of time. I want to thank you three for donating your time and coming and talking about that paper to us. Would you like to recognize any co-authors, people that help with the study, or funding agencies?
Absolutely. So I want to thank all the co-authors, including Kaden Chamberlain, Susan Pritchard, Alina Cansler, Andrew Huda, Craig Bienz, Monica Moscal, Bob Keane, and last but not least, I want to thank the Nature Conservancy and the Joint Science Fire Program for funding this study. Thank you so much.
Those of you listening, if you want to read this paper, guess what? You can download it from the Fire Ecology website for free. Astrid and her crew have already paid the freight for you to read this paper, so you can download it for free, get it, look at it, and be amazed like I was how cool this study was. So with that, please come, and want to thank you three for the wonderful chat that we had from talking about fire ecology, and please come tune in to the next Fire Ecology Chat.
Thank you for listening to Fire Ecology Chats, a podcast series by the Association for Fire Ecology. If you enjoyed this episode, subscribe to our show and leave us a review. To learn more about fire ecology and support our future work by becoming a member, visit fireecology.org. FireEcology.org.